In this short video, I'm going to discuss the fiber separation protocol, which is part of the materials protocol collection. The protocol is designed to separate crossing fibers and measure the length, thickness, and orientation of the fibers. As shown in this example image, the protocol is designed for thinner fibers such as asbestos fibers or fibers similar in structure. To launch the protocol, select the count size ribbon and press the protocols button. Next, select the materials protocol collection and locate the fiber separation protocol. Simply press the load button. All protocols include a demo image or set of images. The protocol is set up by using the associated demo image. If you are using your own image, you may modify the protocol as needed and save it for later use. To load the image, select the drop-down by the reset button and select Load Demo with the Open Demo image checked. Press the Sync button to load the image or image channel names. In this case, this is the monochrome image. The image is currently calibrated, so we'll leave that as current. A region of interest tool is available if you have a marker bar that you wish to exclude. In this case, the image does not have one, so we'll not be needing that. To test the protocol settings, the interactive state is checked and on. Press the Next Step button. The protocol includes a number of parameters to properly identify, separate, and measure the fibers. In this case, we have fiber thickness. Fiber thickness parameter defines the thickness of the fiber in pixels and is used in pre-processing the image to extract the skeleton of the fibers. In this example, two fibers are connected. The minimum length defines the minimum length required for an object to be considered a fiber. The angle deviation defines how much the fibers can be bent to determine if it is the same or a different fiber. The smaller the value, only straight fibers will be detected as separate fibers. The search radius parameter defines the maximum size of the fiber crossing area. The area will be analyzed for fiber connections, such as the area here. The maximum overlap parameter defines the length of the area where the two fibers can be overlapped, but still be considered separate fibers if they have visible exit. In addition, we have dark fibers on bright background, or if this is unchecked, it'll be looking for bright fibers on a dark background. Show preview mask is on. In addition, we have a custom method which, if checked, will allow you to use smart segmentation to do this segmentation of the fibers. To show how some of these parameters affect the fiber separation detection, I'm going to press the OK button. You can see how the fibers are detected. So first, let's look at fiber thickness. As you can see here, this is actually two fibers, and possibly a third, although they are quite overlapped. By adjusting the thickness, bring that down to 3, and pressing the Apply button, you can now see these two fibers have been separated. Show you another example of minimum fiber length. Taking a look here, this fiber was detected earlier through segmentation. However, it has been excluded. In addition, the fiber here has been excluded because it doesn't meet the minimum length requirement. If I bring that down a little bit to say 20 and then press the Apply button, that fiber has now been found. As mentioned earlier, the angle deviation defines how much the fibers can be bent to be determined if it is the same or a different fiber. Here, you'll notice that the fiber is bent. Currently, it's set to 60. If we bring that down using a slider or typing in a number and pressing the Apply button, you can see now, because of the different angle of deviation, now being set to 30 degrees, is now separating this into separate fibers. Bring that back to 60. This is actually a single fiber. And pressing the Apply button again, you can see it is now following this fiber around this bend and considering that a single fiber, which is correct. In addition, we have tools for manually editing the fibers. In this case, I can select the fiber by pressing the Select button. You can see here, it's not actually split into two separate fibers. Part of this is because there's a large gray area here that's involved in the segmentation that matches the gray area of other fibers in the image. Next, I'll select the fibers. And delete them. Select the straight line drawing tool. Then you come in and draw the first one. And then draw the second one. Now the drawing is complete. I'll press the Next Step button. and all the fiber data is generated, giving fiber length, angle, and thickness for the fibers and the fibers that are still from the original segmentation. At this point, I can press the Finish button, and now I can export the data to Excel or send it out in a report.